Hello, in this video we will go over polar coordinates, which is a coordinate system represents a point in a plane by an ordered pair of numbers called coordinates. In this video we will learn to convert to polar to rectangular coordinates and convert rectangular to polar coordinates. We will learn how to graph polar coordinates and how to find coterminal coordinates pairs. Finally, we will convert polar equation to rectangular form and convert rectangular equation to polar curves. Okay, so polar coordinates. You've seen this before in pre-cal or trig. Here you have a Cartesian plane, and you have this point x comma y, right? The horizontal distance is the x, the vertical distance is the y, and then the hypotenuse is the radius. Somehow we have to convert that to so how do we we're used to the x comma y coordinate, right? Somehow we're gonna have to convert that to radius comma theta. So that's what we have to do. So what do we know? We know that the equation x squared plus y squared equals r squared. And we also know that sine theta is the same thing as y over radius. That's correct from trig. And then if you cross multiply, right? Cross multiply, this would give you y equals r sine theta. So we're going to use that when we do these problems. And what else do we know? We know that cosine theta is the same thing as x over radius from your trig course. And if you cross multiply, you're going to get x equals r cosine theta. Okay. And we also know that tangent theta is y over x. Okay. So go ahead and write these down because we're going to definitely use these formulas. Write this one, and this one. Oh, and don't forget the last one. Okay. Got it? Okay, let's move on to example one. Or I mean, let's quickly go over polar system. So polar system is almost kind of like a rectangular, but the thing is our x is the radius and our y is a theta. So what is the radius? So a radius is the hypotenuse, the length of the rings, right? And you just have to remember you're moving right or left. So if it's positive, like let's say your r was 2, right? That means you're going to go 2 rings to the right. So you'd be right here, right? And then your theta is either going counterclockwise or clockwise. So if it's positive, you're going to go counterclockwise. If it's negative, you're going to go clockwise. So for example, let's say they want you to plot a radius of 2 and a theta of pi over 6. Pi over 6 is what? Like 30 degrees, right? How would I do this? So how would I plot this? So if our radius is 2, we're going to go 2, positive 2. So you always start in the origin, right? And then you go 2 rings to the right, right here. And then our theta is pi over 6, so it would be right about here. Okay. So it would be right up somewhere around here. Okay. Yeah, so radius is the hypotenuse, and you're either going 2 rings to the right or a ring to the left. Then your theta is either going counterclockwise or clockwise, depending if your theta is positive. If your theta is positive, you go counterclockwise. If your theta is negative, you go clockwise. Okay, let's do an example one. So example one says graph the polar coordinates and find three other ways of representing the same coordinate. Okay, so here we have a polar coordinate, and we got to find three other ways of representing the same coordinate. So they don't want you to convert it to rectangular. They still want it in polar. They just want, yeah, they just want to there's another way you can write this. So your radius might be negative and your theta could be negative. As long as you're in the same position, it's correct. So let's first figure out, let's plot this. So two, if this is a polar, this two is your radius, and then your theta is positive pi over 3. Okay, so how would that look like? So you start at the center origin, and then our radius is 2, so go 2 rings to the right, 1, 2, right? And then our theta is positive pi over 3, which is really 60 degrees. So 60 degrees is somewhere around here, right? So your dot would be right there. So it would look something like this, right? Okay, now we have to be, oh wait, you don't need this arrow. Actually, you don't even need this. It just stops here. Okay, so you don't need that. So it would look something like this. So how can I rewrite this? As long as I'm in the same position. So what if I change my radius? So what if I change my radius to -2? So that means I would have to go 2 rings to the left, 1, 2. But I have to be in the same position as here. So how would I do that? What would be my theta? Well, I can use a positive theta and a negative theta, and I'm not going to use pi over 3. Instead, maybe I could do positive 4 pi over 3. So remember, if you're going positive, you're going counterclockwise. Okay. Actually, I can use a negative. Let's use a negative. So if maybe I could use -5 pi over 3. Okay, so what is -5 pi over 3? That is, and I know it's related to pi over 3. So negative pi over 3, -5 pi over 3 is -300. So what that means is, would you be in the same position as here? So if our radius is -2, and then I go -300, so you're going this way. So this is -90, -180, and then -300 would be right here. So yeah, that would give you the same position. Okay, what about, let's use a positive theta. So maybe our radius could still be -2. And this time, so if I go -2 here, I want to still be in this same position. So maybe I could use positive 4 pi over 3. So 4 pi over 3 is 240, right? So yeah, I this would be 90, and then 240 would be somewhere around here. So yeah, that would work. So you'll be in the same position. And then what if I use, what's another ways? We need one more, right? Because we want 3. So what if I use -2, and then my theta would be, let's use another negative. What about negative 2 pi over 3? That's like negative 120. So if you go negative 2 ring to the left, 1, 2, and then if I go negative 120, um, yeah, that would give you the same position, right? Yes. So negative is clockwise. Oh, okay. Clockwise is clockwise is going this way. So that's a bit confusing. Negative 2, and then if I go negative 220, negative 120, yes, I was okay. So here's negative 2, and then if I clockwise is going this way, so be careful. Positive is this way, negative is this way. So negative 120 would be here, would be in the same position. If you look at 3, negative 2, comma 4 pi over 3, so 4 pi over 3 is 240. So negative 2, and then you go this way to exactly 240. That would give you the same position. Okay, so yeah, don't get that confused. Okay, so those are three ways you could express 2 comma pi over 3, which will give you the same position as these. Uh, Also, what does this mean in rectangular form? So yeah, let's talk about it. What does it mean in rectangular form? Think all the rings. So yeah, what is our radius? Our radius is 2 and pi over 3. So in a rectangular form, it's like an x comma y coordinate. So what that means is, so if you we saw it, we said it would be your position would be right here. So somehow that forms a triangle, right? This horizontal distance is your x, and then your vertical distance is your y. So we have formulas to find your x, right? We said x equals r times cosine theta, and we said y is r times sine theta, right? So we're gonna have to use that later on when we have to convert from polar to rectangular. Okay, uh, let's do example B. It says graph the polar coordinates and convert from polar to rectangular. Okay, so graph the pole, we have it in polar and we have to somehow convert it to rectangular. So my radius is 4 and my theta is positive pi over 6. So what that means is here's a graph. So we go 4 rings to the right, 1, 2, 3, 4, and then we go positive, or what is it called? At which, at which when you're going in the positive, you're going counterclockwise, right? So 1, 2, 3, 4, and then we're going positive pi over 6. Pi over 6 is 30. So it would be right here, or somewhere around here, right? And oops, and then draw a straight line from the origin. Okay, so this is our position. They want it in rectangular, so we're basically trying to find the x coordinate and the y coordinate, right? We're trying to find this horizontal distance because it forms a triangle, and then trying to find this vertical distance. So what do we know? We know that our formulas are x squared plus y squared equals r squared. And we also know the y coordinate is r times sine theta. And we also know that x equals r cosine theta. And we also know that tan theta is y over x. Okay, so we have 4 comma pi over 6. 4 is our radius, pi over 6 is our theta. So we just got to put it in rectangular, which is x comma y coordinate, right? So we know that the x is r times cosine theta. And we know that our y is r times sine theta. Let's just plug it in. My radius is 4, and my cosine theta, my theta is pi over 6. And my radius is 4, and my sine theta is sine of pi over 6. Okay, so what's cosine of pi over 6? So if you need to go back to your triangle, it's pi over 6. It has an x coordinate of radical 3 over 2 and a y coordinate of 1/2, right? So you can replace cosine of pi over 6 with radical 3 over 2. And then you can replace, so this would be 4 times, and then you can replace sine of pi over 6 with positive 1/2. So this is going to be x, and then 4 divided by 2 is 2, and then you have radical 3. And then the y is, what's 4 times 1/2? That's 2. So your rectangular point can also be expressed as a coordinate as 2 comma radical 3, and your y value is 2. And this would be your final answer. Not too bad, right? Okay, let's move on to example C. So graph the polar coordinate and convert from polar to rectangular. So first, I gotta see where this is in the graph. So this is a polar coordinate. That means -1 is my radius, and my theta is positive 5 pi over 4. So be careful. Can be tricky. Okay, so what means start in the origin, go 1 ring to the left. Now, our theta is positive 5 pi over 4, but careful, we are in this side. So positive is going, you're going to go this way, right? If you're on this side, if you're on this side, we're going to move this way. So go ahead and move to positive 5 pi over 4. 5 pi over 4 is about, or exactly 225. So move 225 this way. So over here, this is 180, and then it would be in related to pi over 4. So it would be right here. It would stop right there, right? So this is our new position. Okay. I know it's related to pi over 4 because look at the bottom. It has a 4 on it on the bottom. So that's where I stop. Okay. Now, yeah. Okay, let's convert it to rectangular. So we know that our x is r times cosine theta, and my y is r times sine theta. Okay, so my radius is -1. Cosine in our theta is 5 pi over 4. And then my radius is -1, and then sine of 5 pi over 4. Okay, so where's 5 pi over 4? 5 pi over 4 is 225. So that would be in quadrant 2. So that means it has an x coordinate of negative radical 2 over 2 and a y coordinate of positive radical 2 over 2 because we're in quadrant 2, right? So it's going to be x equals -1, and then cosine of 5 pi over 4 is negative radical 2 over 2. And then my y is -1, and then my sine is positive radical 2 over 2. And then -1 times negative is positive, so that would be positive radical 2 over 2. And my y is -1 times this is just negative radical 2 over 2. So our final answer will be as a coordinate radical 2 over 2, and then my y coordinate is negative radical 2 over 2. Okay, that's it. Okay, let's move on. Okay, let's do example 2. So example 2 says convert polar to rectangular, and they only give us radius equals 2. So I don't even get how a theta. So how am I going to do this? Well, let's write down our formulas. We know x squared plus y squared. So when they say convert polar to rectangular, so we know that x squared plus y squared equals r squared. And we also know that y equals r sine theta. We know that x equals r cosine theta. And we also know that tan theta is y over x. Okay, so if r equals 2, what can we do? Maybe I can square both sides, right? Maybe, would that even help? Square, because maybe if, see, this is an r square, so maybe if I square both sides, something might happen. So this is going to be r squared equals to 4. And if that is related to this, so we can replace r squared with 4, and then on the left, it would be expressed as x squared plus y squared. So on the left, it's going to be x squared plus y squared, and then on the right is 4. So we use this formula, and we squared both sides. That's why I use this. Does this graph look familiar? Yes, it is a it is a circle, right? It's a circle with a radius of 2 and a starting point of an origin, 0, 0. So I think this would be our rectangular point. It would look something like this. There you go. Okay, let's move on to example 3. Example 3 says, convert from polar to rectangular. Okay, so we have a polar and rectangular. So a polar is like a radius and a theta. They only give us a radius. They don't give us theta. So let's write down a formula. So we know that x squared plus y squared equals r squared. We know that y equals r sine theta. And we know that x equals r cosine theta. Okay. So what if I wanted so here's the thing. What if I multiply, because we need some kind of r squared. What if I multiply both sides by r? By r, right? So we have r equals 5 cosine theta. And then if we multiply both sides by r, you get r squared on the left. And then this is going to be 5r cosine of theta. Okay. Now, we have an r squared, so most likely we're going to use this equation right here. So you can replace uh, so the left side, if we're going to use that formula, the left side is going to be x squared plus y squared. And I think we're going to replace r squared with 5r, or in our case, 5x, right? And as you can see, this is a circle. And believe it or not, this is the equation in rectangular. Okay, so that's all they really want for that example. Let's move on to example 4. Example 4 says convert from polar to rectangular. So polar, in a polar, they give it should be radius comma theta. They only give us theta, pi over 4. Somehow we have to, okay, so let's write out our formulas. Our formulas are x squared plus y squared equals r squared. Y equals r sine theta. X equals r cosine theta. And then tan theta is y over x. Okay, what would I do? What if I related to the tan theta? So would that even help? I think it would. Because I know it can't, we don't have any of this. We don't have an R. We can't use this, this, or this. So we have no choice to use this. So what I would have to do is take the tangent of both sides, right? Uh, Now you have to take with both sides because it won't change the problem, right? So that's not it won't change the problem. So if I take, I mean, if you do it on one side, you have to do it on the other side. That's the rule. So tan of theta equals tan of pi over 4, right? And tan of theta, we said, is also expressed as y over x. And then what is the tangent of pi over 4? It is 1, right? The tan of pi over 4, if you look at your unit circle, it has an x coordinate of radical 2 over 2 and a y coordinate of radical 2 over 2, right? So tangent is y over x, so what's radical 2 over radical 2 over 2? 1. And then maybe I would do is solve for x. So go ahead and cross multiply. So y times 1 is y, and then 1 times x is x. So you get y equals x. Okay. So yeah, that was that one. Let's move on to example 5. Okay, so example 5 says convert rectangular to polar. Uh, Rectangular, so we have a rectangular, so that means this is your x, this is your y, and we have to convert it to polar, which is like radius comma theta, right? So write down your formulas. Okay, what can we do? Well, we have an x and a y, so maybe we can relate it to this formula, right? So we have to square our x's and our y's, and that'll equal to r squared. So there'd be 1 squared plus negative 1 squared equals to r squared. And we know that 1 squared is 1, and then negative 1 squared is 1, and then 1 plus 1 is 2 equals to r squared. And then if you solve for r, you're going to have to take the square root of r to solve for r, and you get r equals square root of 2. Okay? So we have our radius. Now, how do you find our theta? Well, we have an x and a y, so we could find theta using this formula. So tan of theta is y over x, and our y is negative 1, and my x is positive 1. So that's tan of theta equals to negative 1. Well, I need theta, right? So if you would have to take the tan inverse of both sides, so this cancels, so you're left with theta equals tan inverse of negative 1. So what this means is what degree in radians is going to give you a tangent of negative 1? Well, which quadrant can we use? Not 1 because that gives you positive tangent. Maybe quadrant 2. Yes, quadrant 2, not 3, right? That gives you a positive tangent. And maybe 4. So in quadrant 2, that would be 3 pi over 4, right? In quadrant 4, it would be 7 pi over 4. So our theta, we have two thetas, right? We have 3 pi over 4 and 7 pi over 4. So there's several ways we can express this as a polar. So radius, comma, theta. So one way is our radius is radical, positive radical 2, and our theta, one of my theta could be like 7 pi over 4. And then another one would be radical 2. And we can also express 7 pi over 4 as negative pi over 4, right? That gives you the same position as 7 pi over 4. You could also use, your radius could also be, so keep in mind, so if you draw it, remember in the first example, you can make your radius negative and you can change the theta as long as you're in the same position. So yeah. So another way you can rewrite this as, you can also say, you can change your radius to a negative radical 2. And wait, we have to figure out, radical 2 is about 1.4. So here's one ring, 1.4, and then we can go 3 pi over 4. So you have to be in this position. And 7 pi over 4. Yeah, 7 pi over 4 is 315. So here's right here, and then 90. So you'd be right there. Okay, good. So yeah, we can definitely change the radius. So we can, these are your two positions. As long as you're here and here, there's more than one answer. So one of them could be negative radical 2, and your theta could be positive 3 pi over 4. And another one can also be expressed as negative radical 2, and your theta could be also be expressed as negative 5 pi over 4. Okay, so those are your answers. Honestly, I like this one better. Okay, let's move on to last example. Example 6 says convert from rectangular to polar. So polar, if you call, is radius times radius comma theta. And how, this is what they give us. 3x minus y plus 2 equals 2. How on earth are we going to convert that to polar? Well, use your formulas. Okay, so what do we know? Well, we know that x is the same thing as r times cosine theta, right? So I guess you can replace this x with r cosine theta. And then we also know that y is the same thing as r sine theta. So let's do that. So replace x with r cosine theta and replace y with r sine theta. So it'd be 3 times x, or 3 times r cosine theta, minus, and then replace y with r sine theta. And then plus 2 equals 0. And then I guess if you kind of like clean this up, FOIL out this 3, so this would be 3r cosine theta minus r sine theta plus 2 equals 0. And then what we can do is maybe move this constant to the right by subtracting 2. And then from here, what we could do is maybe like factor out an r. So it's r times 3 cosine theta minus sine theta equals to -2. So if you solve for r, that's what we need. We need a radius. You would have to get rid of this by dividing both sides by itself. Okay, so that means that your r is going to equal to -2 over 3 cosine theta minus sine theta. And that's your final answer. Okay, I guess we can stop here. So yeah, we'll stop here.